Oh, shh. Hello, my name is Noe Avila. And I really like woodworking. I like making stuff. And I wanted to apply some of the properties and things I've learned in 9th grade geometry to my projects. And I kind of wanted to make like a little fidget type of thing. But I know I studied triangles, so by using the centroid of a triangle, the centroid is basically when you find the midpoints of each of the segments, then connect them to the opposing vertexes, it creates this little point right in the middle. I don't have it right now, but I'm going to be showing you how to make a balancing triangle. And we're going to determine where the centroid is so we know if we can balance it or not. For this part, I'm just going to see if I can draw a triangle. So I have my pencil. I have a ruler. I don't really know where any metric rulers are, so I'm just going to be using an imperial inch ruler. Okay, for this, I'm just going to be drawing a triangle. Any type of triangle. It can't be isosceles, can't be right. But this centroid theorem, it'll work with any type of triangle. So let's go 4 inches, then 6, 5 inches. So 4, 5, 6. They're all separate distances. And basically what we're going to be doing is connecting the midpoint to that and the midpoint of this to that. Now, I'm going to be showing you the math later, but right now I don't actually have like a grid or anything to be using. So let's find the midpoint of 4, and that's going to be 2, because 4 divided by 2, duh. So that's our midpoint, and the midpoint is 6, measured out, that's 3. And the midpoint of 5 is 2.5, which is right about there. And we're going to be connecting that to the separate vertexes. Let's just call it vertex A, B, and C. And let me adjust my camera angle. Vertex A, B, and C, and then we'll have midpoint, let's call it M, N, and O. These are going to connect to our separate vertexes. This is going to connect to that vertex, G to B. And N to C. Now this little point right here, that's what we call our centroid. That's basically the balancing point of the triangle. Now, let's cut this thing out. Alright, now we have our triangle cut out. Unfortunately, this side, right here, how does this go in? This wasn't cut exactly on the line, so I'm going to need to redo the centroid. Fortunately, this is wood, and we can use the back side of it. Yeah, that's centroid G. So that, if we balance it, what do you know? That works. See? It's a balancing triangle. Now let's clean this thing up. Now we're not going to really get cut or anything by our triangle. And centroid G, that's what we want. Alright, I did a little bit of working with my drill, and it balances on your finger. So this is how the total centroid model came out. This is a different triangle because the original one was not cut correctly. But what I did to find the centroid right here is I just found the midpoint of each of these, drew it to the vertex, and at the intersection I drew a small pilot hole, then bored it out with a bigger drill bit, then put different magnets, and later I made this little stand. So it's not a perfect centroid, but this one does do very well. Now, how exactly would we find a centroid in a graph? So I have a graph right here, and these points, they make a triangle. If I connect, well, let's just, first off, let's label these points. It's point A, B, C, and we want to be able to find the centroid of this triangle. And this is the same stuff I use to work and find this little piece of wood. How to find the centroid of it. So let's use the midpoint formula to find the midpoint of 0, 0, and 5, 0. x2 plus x1 over 2. y2 plus y1 over 2. I already knew I wrote that comma. And so let's plug these numbers in. So x2, let's make that 5 plus 0 over 2, comma, 0 plus 0 over 2, pretty easy equation, 2.5, comma, 0. So that's our midpoint of CB. And all you really need to do to find the centroid is just get two midpoints, because if you have two intersecting lines, let's just say you go that to that, that's going to give us the same thing if we were to do this. They all measure equally, and that's our little centroid. So let's find midpoint of AB, and we can just use those two segments to connect them to the vertexes. So 5 plus 0. That is not 4, 0. I knew that. Five plus 0 over 2. 0 plus 4 over 2. That's going to give us 2.5, comma 2. 2.52. And we already have the lines drawn, so we just have to find where they intersect. That's going to be interesting. All I need to do from those points and their opposite vertexes is find the equation of a line. First I'm going to use slope, and then I'm just going to plug it in and find y-intercept. I've finished calculations for one of the lines, and y is equal to 1.6. I've also found that y is equal to 0.8x for the A to the CB midpoint, the equation of that line. Now I'm going to perform a system of equations in order to find the centroid. I found that the centroid is 2, 0.8. I know this diagram right here is definitely not drawn to scale. It's loosely done, but I've plugged in numbers and stuff. So we know that that's definitely true.